API Design Paper Summary. Do you think that building an API is a solvable question? For example, if I give you a problem for which you need to design and create an API, is it a bulletproof way for you to come up with the best API? And how far can we get into having good APIs, and what is a good API at all? These are all very hard questions. Usually, you know the answers once you have designed multiple APIs and got experience and reviewed the decision that you have taken. Fortunately, there are papers dealing with this problem exactly. There are complex APIs used by huge amount of people. For example, the Qt API is a very popular API for a desktop GUI building. This is an API where software developers use it, and a library that software developers use in order to create desktop applications, and it's super popular and it has been here for a while. Today we are going to go through the summary of the paper that deals with designing good APIs and the lessons learned from building the APIs of the Qt desktop building app framework. The paper is called The Little Manual of API Design, and I'm going to summarize it for you. It is a very nice paper written by Jasmin Blanchette, which has released a paper while working on trolltech company. The trolltech company was acquired by a Nokia. So you could say that this API design paper was created by Nokia. I found it to be very clear and concise. And it's also reassuring what we think of API design. It's a difficult task that includes both artistic, social, and programming and scientific skills. We are going to summarize this paper for you. When you write an API, you combine a set of symbols and export it for users to use, so that they can build their applications on top of your API. You can think of an API as one of the major abstractions of your software. This is the abstraction that users are going to see. It's the language of the library. This is the external meaning of your library. And when designing it, it's going to affect your whole software design. In this paper, Jasmin is going through the lessons she learned by designing one of the most used API for GUI building libraries, which is used heavily in many applications that you use on a daily basis. This is the Qt library, which is used for building GUI for desktop. These applications have been built by Nokia when they acquired trolltech, and trolltech is the one that has designed the very popular Qt library with which you can build cross-platform desktop applications, which means it's suitable, the API is suitable both for Windows, Mac, and Linux. The paper describes a list of what makes a good API. This list is inspired by Joshua Bloch, who is the creator of the Java Collections API and is the author of Effective Java Book. For an API to be considered a good API, it should be 1. Easy to learn and memorize. 2. Leads to readable code. 3. Hard to misuse. 4. Easy to extend. And 5. Complete. What about minimal API and consistent? Why doesn't it appear on the list? Isn't it important? Well, actually, it's very important, but the answer from the paper is that if it's not minimal, then it's not consistent. It would not answer the bullet number 1, which is easy to learn and memorize. So if the API is not consistent and not minimal, then it would not be easy to learn. So easy to learn is like a superset of this functionality. And therefore, the most important thing is that the API would be easy to learn as part of the 5 characteristics of good API, which are easy to learn and memorize, leads to readable code, hard to misuse, easy to extend, and complete. So when you design your API, make sure it's easy to learn. To make an API easy to learn, you need to reduce the cognitive load that you put on the user by making the API, for example, more consistent, and also by having conventions and by having patterns, so the user can move fast from API to API. The ultimate goal that we want is that the user could simply guess the API without any code completion. A minimal API, for example, is easier to learn than one which is not compact. I used in the past an API, for example, that required me to write a lot of code just to call the API. You need to prepare this object and that object and compose the object, and only then you could call the API. That is not an easy to learn nor an easy to use API. You could add for that purpose convenience methods, which do all the boilerplate, instead of the client which calls the API. The paper then moves on to share what's its view on convenient API. The term that we say when we specify convenient APIs is like an abstraction over the API which makes the rest of the API simpler. It moves ahead to say that if you have a method for, let's say, take for example a method that is called add item with 2 arguments, the index and the item to add. Then a convenient API could be the same method without the index, with the default. Or that if you have an API that instead of a function or constructor is receiving multiple parameters, then you can split it with the builder pattern. Or with multiple setters, because calling a function with many parameters is difficult for the eye. When you look at it, it's difficult. Although it may be more concise, it's difficult, and it's much more easier to view an API where you call a method with a few params and then you add the additional params with setters. Yes, setters have their own problems, but in manner of APIs, sometimes the trade-off of using setters and making the API easier is larger than having like a full complete method signature. I have to say that this is pretty obvious, and I'm a little disappointed at this point on the paper, because if you already, that paper treats it as if you already decided what are the objects, what is the API. It already decided that you need the add item and that you need an index and item, and only dealing with the technicalities of whether it's better to have a large function or a small function or setters. And these are technicalities. Because if you already know that you need a certain property in your API and you need to decide between one function that receives multiple parameters to multiple functions that receive each one param, this is like a great case. You're already at a very good point in your API design. Because I think that the real challenge in API design is when you're not sure which functions at all should your API contain. You're not sure which parameter versus another do you want, and it's not the case that whether the parameter should appear in a single method or in two, but whether this parameter should appear at all. So the case of whether you want a large, medium headers, or do you want actually the user to specify the exact size, for example, of a header. The real challenge is not this. The real challenge is whether you need, what are the properties of the, let's say you have an API to add a header to a document, and the real challenge is how do you want the user to specify exactly what is the header. An API which is hard to misuse, which is another point in the document, means that it's easy to write correct code than incorrect code. When you use the API, one of the best ways and one of the best gifts that you can give your users is that it would be easier for them to write correct code than incorrect code. For example, the HTML API designers originally recommended its users to use the strong tag rather than the B tag, which is for bold. But SB is much easier, much compact, and much easier to remember than users did not use the strong. But if the tag B was like font style equals bold, then in most cases users would prefer using the strong because it's more compact. So you should encourage your users and you should direct them, even psychologically, to use the more compact APIs. And it should be easier for the users to write correct code than incorrect code, and this is how you design the API. And I have to say again that as much as I like these recommendations, these are still dealing with pure technicalities and not with the core real issues of API design, which is what should appear in the API design document. It is much a tougher of a question. The additional bullet point from this API design paper is from Nokia is that it should be easy to extend. Because libraries grow over time and APIs should be designed with this in mind. How do you do this? How do you design an API which is easy to extend? An example of that could be that if you accept an enum in the API, then you could introduce a new enum value for the users to use. And you could, in this way, extend the API. If you abstract the inputs of the API in objects, then you could add new fields to these objects, and you do not restrict the API for certain types which you use currently and for certain fields, but you abstract over them. Another bullet is that APIs should be complete. A complete API is an API that allows users to do everything they want to do with the library, and which is abstracted below it. Now, it's impossible to be fully complete, to have a fully complete API. But the important thing here is to allow your API to get complete over time, not to block it. You do this mainly with the previous item, with the ability to extend the API and to add to it, so that each enhancement of the API is one step forward into completeness. Next, we investigate some guidelines that would enable you to have a good process, the process behind designing your API. The first thing is that you should know the requirements. The solid requirements knowledge is the basis for a good API design. Before you solve a problem, you first need to know the scope of the issue well. In many cases, you are solving the wrong issue. You must know the problem that the users are trying to solve. This is what your API is going to answer. So you had better know very well the question. It could be the case that users themselves don't know the question, so don't trust only what the user is saying. But think, what is the real question? What is the real need behind the users? Design the API before the implementation. If you go straight into the implementation, it's like coding before thinking. If you design the API before understanding the use cases, it might result again in wrong API. And the well-designed wrong API could be worse. In fact, is much worse than less designed but correct API. That is solving the correct problem. Another tip for the design process of the API, and it's one of the best tips here, is to look for similar APIs in the same library and in the same problem space. This pretty much goes without saying that when you add or update or create an API library, check the rest of the APIs in this library and make sure that you conform to them, use the same terminology, and learn from them. Not only from this library, I would say from other libraries which are similar to your API. Another important item in the process of creating your API is to do peer review. And this is something that I add that was not really existing in the paper, but I must add it. And the API is an irreversible implementation. You must do whatever you want, whatever you need to get feedback before you actually release it. Another item that they specify in the paper is that when in doubt, leave it out. If you have your doubts about an API or functionality, you can just leave it out or mark it as internal and reconsider it at a later point. It often helps to wait for feedback from users, and on the other hand, it is practically impossible to add every feature suggested by users. So a good rule of thumb to wait until at least 3 users have independently asked for a feature before implementing it. But I would then add what happens if there is a single user that needs the API. So you could open an experimental or beta API, and once you get enough users, just notify the user that this is beta or experimental. Once you get 3 users, then make it official. The next item that you should do in the design process is to write several examples against the API. After you have designed the API, write examples against the API. This is very trivial, I have to say. And I will share my own insights about API building below, but as much as trivial as this item is to write examples against the API, this is also super correct and you should never neglect it. Prefer specific names to general names. Remember that names occupy API real estate. Once a name is taken, it cannot be used for something else. This is especially an issue with class names, since a library might contain hundreds or even thousands of classes that need distinct names. Another reason for preferring more specific names is that they are easier to use and to relate to. Also, avoid making your APIs overly clever. We observed earlier that the semantics of an API should be simple and clear, and follow the principle of the least surprise. If an API is too clever, for example, it has subtle side effects, then the users would not understand it as well and will find themselves with subtle bugs in their applications. Cleverness also contributes to making the code less readable and less maintainable, and increases the need for documentation. This is good. This is correct also for general software development. Avoid making it overly clever. Now, to my personal take on the API design paper. While you should do your best to predict the use cases, my personal take is this. Do whatever you can to get early adopters for the API that you have control of. Meaning, experiment with the API. Try to have enough time, even to be by yourself, as a consumer of it. Convince people to be early adopters, to test the API. These are my own views, this is not from the paper. It does not matter how smart you would not be able to predict the requirements. So, do experiment. Even if you think you cannot experiment, try at least to get some time where you are a client, or find clients for your API. Unfortunately, the paper did not really deal with this. I think it had good tips, but those are not the hardest questions in API design. It's like the simpler questions. In fact, those are pretty simple questions, but the paper is fine nevertheless. There is also a notion that says that API should scream. While this sounds too extreme for me, this means a few things for me. API should be specific and not overly generic. Instead of using a get, use get taxi method. In this way, you look at the API and you know exactly what it's about. It's not about getting a general item. It's about getting a taxi. It's screaming it. It's easier for users to use. And as we already talked, here is another tip. Find an API that is heavily used in the industry that has a very similar use case to yours. See which API they exposed. You could learn so much from the experience of a previously designed API in the same domain that you have. Communicate about the intended API. So you can find users to use the API and you still want feedback. What if you can't find any users and you want the feedback? So it would be best to send the expected API to potential consumers and gather early feedback. This does not mean that you need to align with what they suggest, but in many cases you need to take what they suggest, process it, and update the API and send it back to the consumers and see which additional feedback you get. So designing an API, to sum up, is like a product. You ship a product to customers. And when designing API, you should be first super sure about the question you are trying to solve, then understand the solution, then think of the API, do review as much as possible, write examples, write tests on the API, share it with friends, hopefully with clients, be prepared for mistakes, have like a route, what do you do if you have a mistake in the API, be specific in the API, remember we said get taxi and not get, and make it easy to understand the API. This was a review and in additional my own view on the API design paper. See you next time.